Hi, let's look at time series today. What is time series? Any variable that is measured over time in a sequential order is called time series. In other words, a time series value, these are values recorded over a period of time. There are four components of time series, or there are four factors that influence time series values. Number one is the trend. What is the trend? The trend is the long-term tendency or behavior of data. Number two, seasonal variation. What are seasonal variations? These are short-term fluctuations that are usually caused by the changes in the seasons of the year. Cyclical factors. These are long-term fluctuations between medium to long-term fluctuations that are usually caused by the changes in the trade cycle. What are the number four? Residue or irregular factors or random factors. These are unpredictable fluctuations in the data that are caused by things like strikes, accidents, breakdowns, and anything of such nature. There are two models that are used to calculate time series. The first model is called the additive model. Under the additive model, we assume a time series value is the sum of its components. Sum of its components. So we get the trend plus the seasonal variation plus the cyclical factors plus the random factors. Under the multiplicative model, we assume a time series value is the product of its factors or product of its elements. So we multiply the trend by the seasonal variation, by the cyclical factors, by the random factors. Now, in real terms and in our syllabus, we are not required to calculate the cyclical factors and the random factors. So we leave the cyclical factors and the random factors out of the equation. That means our additive model will now be y, the time series value, equals to the trend plus the seasonal variation. The multiplicative model will read y time series value is equals to the trend multiplied by the seasonal variations. Why are time series values important? These values are important because we use them in forecasting. So there is a way we can forecast and predict what we expect to see in the future, having looked at the trend and the seasonal variations. So how do we calculate the trend? There are different methods that can be used to calculate the trend value. Number one method is the semi-average method. Under this method, you divide the data into two groups. Semi means two, and find the average for each group and then plot those averages on the XY plane in order to determine the line of best fit. Number two, you can use the least square regression analysis method. This is where you come up with an equation, y equals to a plus bx, and that becomes the trend equation. Number three, you can use the moving average method. In this particular video, I want to demonstrate the moving average method of calculating the trend values. How do we calculate the seasonal variation values? With the seasonal variation, you just have to make S the subject of the formula. For example, in the additive model, we said y equals to t plus s. Make s the subject. S will be equals to y minus t. When t shifts to the other side of the equation, it changes the sign from positive to negative. Under the multiplicative model, make s the subject of the formula. You have to divide both sides by t. So s is going to be equals to y over t. So those will be the ways of calculating the seasonal variations, and depending on the model you are using, whether it's additive or multiplicative model. Additive model, that will be S. Multiplicative model, that will be S. So let's look at our first question. The following data shows the annual sales for Kafue Limited. Use the three moving average to compute the estimated values To compute estimated values to do decimal places, 5 marks. So what are we computing? We are computing estimated trend values. Trend values by moving average method. So 3-point moving average method. What you need to do is come up with a table that will help you sort out those things. Now in this table, you are calculating the moving totals and then calculate the moving average. An average is the sum of values divided by the number of values. So let's start. We have the data that is given, which is the time series data. Bring it down, copy it down there. 3-point moving average means this. You are going to have 3 values that you are going to add at each stage. So adding the first 3 values, 320, 366, and 390, put them together, what you have there will be your moving total. Okay, so having our 3 values added together, the sum should come right in the middle of the 3 values. So the middle of the 3 values is that. And so what's the total there? The total is 1076. That divided by 3 to convert the value into an average, that is going to be 358.67. Then you add the next set of 3. The total should come in the middle of those values. That's the middle of the values. So the total of the next 3 values is 1178. That divided by 3 to convert into the average, that's 392.67. Then you add the next 3 values. You have to be consistent. The next 3 values, the total comes right in the middle of those 3 values, and the total is 1268. That divided by 3 to convert into the average, it's going to be 422.67. And then the next set of 3, like that, the next set of 3, put your answer there. The total should be 1438. That divided by 3 should be 479.33. Then add the next set of 3, put the answer in the middle. That should be 1532 divided by 3, that should be 510.67. 510.67. Add the next 3 values like that, answer put it in the middle, that should be 1820 divided by 3, 606.67. 606.67. Then add the next 3. That's what we mean by moving average. Just keep on going like that. Add the next 3 values, the answer put it in the middle. So the next 3 values like that, put the answer in the middle. That should be 1950. That divided by 3 should give you 650. 650.00. And add the last set of 3 and put your answer right in the middle. It's going to be 2070. And that divided by 3, it's going to be 690.00. Why are we dividing by 3? Because we are getting the sum of 3 values. It's an average, it's just the mean of those values. Sum of the values divided by the number of values, that's what we are doing. So this question is done. That's all you needed to do. It is one of those questions I picked from one of the question papers for 1.2 statistics 1.2 for Zika. Done. Let's look at the more comprehensive example. A small enterprise quota sales for 2001, 2002, 2003 as shown in the table below. So these are the values that we have required. use the 4-quarter sales moving average trend values. So calculate the trend to one decimal place using the 4-point moving average. So we are doing the 3-point moving average because we are adding the 3 values and calculating the average for the 3 values. And we did not need to center the averages. The very averages we got here became our trend values. The averages we got here became our trend values. Why? Because the averages are already lining up with the periods of the year. Well, if we use the 4-quarter or 4-point moving average, the averages we'll get will not line up with the periods of the year, therefore we need to center them. That's why we're going to have the centered averages, which we are going to take as the trend values. So all we do here, get the quarters, the year, and get the values. These sales values are the ones that we have been given here. Those are the sales for the quarters of the year. For example, 2001 sales for quarter 1 is 10, sales for quarter 2 is 8, quarter 3 is 6, quarter 4 is 7. So those are the values that we have. Now this is the 4-point moving average, which means we are going to be adding values in sets of 4. So if we get our first set of 4 values, that's the first set of 4 values, the answer, the total, will put it right in the middle. The mid of the 4 values is this space here. That's why I'm going to put the answer there, or the total. So add 8 plus add 10 plus 8 plus 6 plus 7. What should be the total? The total should be 31. Then add the next set of 4 there, 8, 6, 7, and 5. The total should be 26. Add the next set of 4, 6, 7, 5, 6. The total should be 24. The next set of 4 should be 7, 5, 6, 9. The total should be 27. The next set of 4, that's 5, 6, 9, 8. The total should be 28. The next set of 4, that should be 6, 9, 8, and 7. 6, 9, 8, and 7. The total should be 30. The next 4 values, that is 9, 8, 7, and 10. The total should be 34. The next set of 4 values, 8, 7, 10, and 6. The total should be 31. The next set of 4, 7, 10, 6, 5. The total should be 28. Now we are adding 4 values. So for us to find the moving average, we have to divide those totals by 4. So that 1 divided by 4, that's 7.8. 26 divided by 4, that's 6.5. 24 divided by 4, that is going to be 6. We have 27 divided by 4, that's going to be 6.8 rounded off. And we have 28 divided by 4, that will be 7. 30 divided by 4, that will be 7.5. 34 divided by 4, that is going to be 34 divided by 4, that is going to be 8.5. 8.5. Then we had 31 divided by 4, that is going to be 7.8. Lastly, we have 28 divided by 4, that is going to be 7. What you notice here is that our moving averages are not lining up with any period of the year this side. They are not lining up with the quarters of the year. So what we need to do is to center those moving averages. Center those moving averages. So you get the centered moving average here. So what is the centered moving average? You'll be adding the two averages, find the average and put it right in the middle. The next two values, find the average and put it in the middle. So it is 7.8 plus 6.5 divided by 2. You should get 7.2. The next one is 6.5 plus 6 divided by 2. You should get 6.3 rounded off. 6 plus 6.8 divided by 2. You should get 6.4. You have 6.8 plus 7 divided by 2. You should get 6.9. 7 plus 7.5 divided by 2. You should get 7.3. 7.5 plus 8.5 divided by 2, you should get 8. 8.5 plus 7.8 divided by 2, you should get 8.2. Then lastly, 7.8 plus 7 divided by 2, you should get 7.4. So those are the centered moving averages or centered averages, and you notice that the averages are now lining up with the quarters of the year. For example, for quarter 3, that's the average we have. For quarter 4, that's an average we have. So we will call these averages as the trend values. So next, calculate the seasonal values. The seasonal values using additive model. Seasonal values using additive model. That's the question there. Seasonal values using additive model. So if we are using additive model, our S is going to be Y minus T. Y minus T. So we have the Y values, which are sales values, and we have the trend values, the centered averages we have calculated. So what we have there is 6 minus 7.2, you will have negative 1.2. Then 7 minus 6.3, you have 0.7. Then 5 minus 6.4, you have a negative 1.4. Then 6 minus 6.9, you have a negative 0.9. 9 minus 7.3, you have a 1.7. 8 minus 8, you have 0. 7 minus 8.2, you have a negative 1.2. 10 minus 7.4, you have a 2.6. So those are the seasonal values you have. But finally, you need to summarize those seasonal values into seasonal index values. So how do you do that? You bring down these values. You just find an average per period. So create a table where you can use to calculate the seasonal index values. So if you notice from our seasonal values, we don't have the seasonal value for quarter 1 and quarter 2. So it starts from quarter 3. So meaning that we have nothing there, nothing also for quarter 2. But quarter 3 we have a negative 1.2, and so you pick those values there. The next one is 0.7. Take the 0.7 for quarter 4. Then the next value is negative 1.4. Negative 1.4. Get it there. Put it there in the table. The next one is negative 0.9. Negative 0.9. We have it there. The next one is 1.7. 1.7. The next is 0. Our seasonal value was 0 there. Let's bring it down there. It was 0. Then the next one we have is negative 1.2. That's for quarter 1 of 2003. Then the last one we have is 2.6 for quarter 2 of the last year. Again, you'll notice that we don't have anything there, nothing for the last quarter as well. So all we need to do is get the totals, then get the average, and we'll see what average we are going to have. So the total here is going to be negative 2.6. That's the total. What will be the total there if you had negative 0.9 plus 2.6? What should be the total? The total should be 1.7. There, the total will be negative 1.2 plus 1.7. The total should be 0.5. Okay, so 0.5. Then there, when you had that plus 0, that will remain 0.7. So the next thing you need to do is, because you have added the two values, for you to find an average, take the total divided by two values that you've added. So the average for quarter 1 at this stage is negative 2.6 divided by 2, that is going to be negative 1.3. What's the average there? 1.7 divided by 2. 1.7 divided by 2, that is going to be 0.9. That's a rounded off figure. Then 0.5 divided by 2, that is going to be 0.3, round off to the nearest one decimal place. And 0.7 divided by 2 is going to be 0.4. 0.4 rounded off to the nearest one decimal place. 0.7 divided by 2 is going to be 0.35. Round off that one, you have 0.4. So these are the averages that we have. So the next thing you need to do is to calculate the sum of those averages. Calculate. So try to add the average. When you had negative 1.3 plus 0.9 plus 0.3 plus 0.4, you will get a remainder 0.3 as a positive value. Now the rule says that if you are using the additive model, when you add the seasonal index values, you must get the answer equals to 0. So how do we get our answer equals to 0? You will say we need to subtract 0.3 from the averages that we have, so that our absolute answer for the additive model should be equals to 0. If you are using the multiplicative model, you adjust until the sum of those index values add up to 4 if you are using the 4 quarters, and if you are using the 5 periods, it must add up to 5. It just must add up on the average of 1. So let's adjust. All we need to do is subtract 0.3 from the average figures we have, and we call those as adjustments. So take the negative 0.3, negative 0.3 divided by 4, because you have to share that amongst the 4 values. What you get should be a negative 0.075. Negative 0.075. So this is the value that you are going to use as an adjustment to the figures, as an adjustment to the averages. So copy that. That comes there as an adjustment, goes there as an adjustment, there as an adjustment, and there as an adjustment. The sum of these adjustments is what is giving us negative 0.3. So now it's a negative 1.3 plus a negative 0.075. You have a negative 3.75 when you add those two. Negative 1.375. Negative 1.375, like that. Then 0.9 minus 0.075, you should get 0.825. 0.3 minus 0.075, you should get 0.225. 0.225. And 0.4 minus 0.075, you should get 0.325. 0.325. After making adjustments and you had the index values, your sum must be equals to 0. And now these are going to be our index values, the values we use for all seasonal variations for each of the periods. So for all quarters, all first quarters of the year, the seasonal variation will be that one, as long as the first quarter of the year. The all second quarters of the year, the seasonal variation is going to be that one. All second quarters of the year, the seasonal variations will be that. For all third quarters of the year, the seasonal variation is going to be that one. All third quarters of the year, that will be the seasonal variations. For all fourth quarters of the year, it will be dot value. All fourth quarters of the year, those will be the seasonal variations. So when we move on to the next year, what will be the seasonal values? Seasonal variations are going to be the same values. When we move on to the third year, quarter one of third year starts from there, the seasonal variations will be the same. So if you are forecasting for the next year, the seasonal variations will remain the same for all quarters of the year. So thank you so much. I've done what was required in this question. The other additions that I can just explain to you, you can do them on your own, is the fact that if you are forecasting, for example, you are forecasting for 2004, the seasonal variations for all quarters will be the same, but how do we forecast the trend? To forecast the trend, you need to find the mean change in the trend values. So what you're going to do is 7.4 is the last trend value we have minus the first trend value that we have, 7.2, which is 0.2. Now that 0.2 divided by the number of trend values, 1, 2, 3, 4, 5, 6, 7, 8. So 0.2 divided by 8, what you're going to get is the mean change in the trend values. So you will keep on increasing the trend values by that value. Thank you so much for sparing your time to